These are your 4-8 notes, graphing and solving quadratic inequalities. We are actually going to just concentrate on the two variables in these notes, so we are not going to be solving quadratics in one variable, the inequalities. So in two variables, we simply graph the related quadratic function, determine if the parabola should be solid or broken, and then test a point not on the parabola. So we always shade true. So a lot of review concepts here. To graph, if you have it in standard form, if the equation is given in standard form, to get your vertex, you have negative b over 2a, and then you got to plug that in. Also, if it's in standard form, your y-intercept is c, just as a review. If it's in vertex form, you have the vertex. Your vertex is h and k, but unfortunately you do not have the y-intercept. So you're allowed to put a vertex form into quadratic form. You're allowed to put quadratic form into vertex form if you'd like. We have all those different concepts. Plus, when you're in class, you will have the option of using the graphing calculator for these things. Remember, when you graph, we need 5 points. So we have to have the vertex and then 2 points on each branch. So there's your 5 points. You'll have a table of values. After you graph the related function, we got to determine, do those ordered pairs work for the inequality or not? So if it's going to be solid if it's less than or equal to, greater than or equal to, because we include those ordered pairs. It's broken if it's just less than or if it's just greater than. We're going to test a point not on the parabola, and we shade true. So remember, we're going to have these parabolas. We just want to make sure that if we're going to pick a point not on the parabola, if I pick 0, 0 in this particular instance, 0, 0 is representing every single ordered pair on the outside of the parabola. And so just like absolute values, when we had the v, we're going to pick and we're going to shade. We're either going to shade inside or out, not above or below, but it'll be an inside or an out type of thing. So let's go ahead and try these. Y greater than negative x squared minus 6x minus 7. So this is in standard form. When it's in standard form, I can quickly see that my y-intercept is 0, negative 7. I could put it into vertex form to find my vertex, or I can use negative b over 2a. So I'm going to do x equals negative b over 2a. Okay, we always calculate this value whether we're using a graphing calculator or not. It helps us understand, will the table of values be symmetrical? Are we missing a value? Do I need to calculate the value using the calculator? So x equals, opposite of b is 6 over 2 times negative 1. That's 6 over negative 2, which is negative 3. So what that tells me, if I was using a graphing calculator, I can go straight to the table of values, and everything should be symmetrical around negative 3. Now, you don't have a graph calculator at home. I don't have one here. So if we didn't, I want to show you by hand how you figure out the rest. So we got to calculate the y value of my vertex. So we simply take this negative 3 and we plug it in to x in the equation. So y equals, now be careful, the negative out in front of the x squared is the negative of the function, parentheses, then negative 3 squared. You cannot combine those negatives first. You have to do the exponent first, then multiply by the negative 1. Minus 6 times negative 3 minus 7. So this actually simplifies to a negative 9. Negative 3 squared is positive 9, but then we take the opposite sign of it. A negative 6 and a negative 3 makes positive 18 minus 7. Negative 9 plus 18 is 9, minus 7 is 2. So I get my y coordinate, or for the vertex, is 2. So negative 3, positive 2 is my vertex. I also have the ordered pair 0, negative 7, which is to the right of this. 0, negative 7 is right here. That's 3 units to the right. So negative 6, negative 7 is another ordered pair that belongs on this parabola. And so I'm going to graph that matching pair. And I just need one more point. I'm actually going to go to -1, which is just inside of the 0. And so then -5 would match up. When I plug in -1, I just plug it into the equation. Again, the negative from the function. Then I square -1 minus 6 times -1 minus 7. Lots of negatives there. Y is equal to -1 plus 6 minus 7, which actually gives me -2. So when x is -1 in this parabola, y is -2. So -1, -2, -5, -2, and there's my symmetrical parabola. So I'm going to connect and extend as best as I can in a parabolic fashion. There's my boundary. So I've created my inside and my outside boundary. The numbers on the boundary do not work because it just says greater than, so we have to break the boundaries. And what that tells me is when I plug those ordered pairs in, they will not give a true statement. If I plug in the vertex -3, 2, I'll get -7 is greater than -7, and that's incorrect, or something along those lines. I'm going to pick a point for shading. I'm going to pick 0, 0. 0, 0 is clearly on the outside boundary of the quadratic. So 0, 0 represents every single ordered pair on the outside of the parabola. If 0, 0 works, I'm going to shade all around the outside. If 0, 0 doesn't work, that tells me that all of the ordered pairs on the outside do not work. And so the inside would be the solutions. So when I check 0, 0, I just plug those two values into the original inequality. Is 0 greater than -0 squared minus 6 times 0 minus 7? Well, the funny thing is when you multiply by 0, I don't care if you square it, if it's positive, negative, multiply, all of that junk goes away. So what we're left with is 0 greater than -7. This is a true statement. So because 0 is greater than 7, I get to shade on the outside. I probably should have showed my work in a different spot other than where I'm shading. So we're going to shade on the outside because 0 is greater than -7. And there you have it. In this last example here, y less than or equal to x squared minus 3x plus 2. Okay, I have x is equal to -b over 2a. X is equal to a positive 3 over 2 times 1, which is 3/2, which is 1.5. So that tells me on a graphing calculator that I won't have exact symmetry. I'll have back-to-back symmetry, but I'll have to calculate that y value because remember, halves don't show up in our table of values. So 1.5 something is my vertex. I also know that this positive 2 is my y-intercept. So I'm going to put that in there as well, 0, 2. And so that means that 3, 2 is another ordered pair I have. So I got to find my vertex. So I'm going to plug 1.5 or 3/2 into this equation. Y equals 3/2 squared minus 3 times 3/2 plus 2. I like to work with fractions. 9/4 minus 9/2 plus 2. 9/4 take away 9/2 is a -9/4. So I have a -9/4 and 2 is 8/4. -1/4. If you used your decimal or if you used your calculator, you should get -0.25. So there's my vertex. I go over 1.5 units and up 1/4. 0, 2 and 3, 2. So I'm actually going to go a little bit further out. I don't really need the points in between those, so I'm going to go to +4 and -1 for my next ordered pairs. So when I figure those out, y is equal to, I'm just going to plug in -1. I got to be careful. I'm going to square the -1. I got to subtract 3 times -1 and then add 2. So when I square -1, it becomes +1. -3 times -1 is a +3 and then +2. And so y is equal to 6. So -1 gives 6. Again, the graphing calculator will do a lot of this for us. 4 gives 6. There's my boundaries. Connect and extend in a parabolic shape. This boundary is going to be solid because of this equal sign. So that means that we're going to have a solid graph. And that means that all of those ordered pairs I just picked will work when I plug them into the inequality. We got to check a point. I can use 0, 0 again, and 0, 0 again represents points on the outside of the parabola. So when I check 0, 0, and check it off the page this time, is 0 less than, well, when you plug 0 in and square it, you get 0. When you times it by -3, you get 0. So I get 0 less than 2. Is 0 less than 2? That is true. So I'm going to shade outside once again. And there you have it. A lot of review from when we shaded before. So your lesson summary, oops, sorry about that. Would the boundary of the graph be solid or broken for that function below? And then explain why. And for the practice problem, I want you to graph that inequality. Be careful, try to be accurate because I forgot to give you a grid line. So you want to make sure that whatever point you pick with is truly on the inside or the outside of that boundary. Good luck.